I would like to talk today more about Python functions and get back to one of the examples we discussed before. So let me define a function which calculates the hypotenuse using the Pythagorean theorem. Okay, so it needs two variables as an input, right? And it calculates c as square root of a squared plus b squared, right? And it will return c, right? And if I say print hypotenuse, and let's say I'll take the numbers 3 and 4, run it, hopefully it's going to work, right? How am I supposed to know what my function is doing? I mean, this is a simple function, well, its name is obvious, and also the way we call the variable is sort of semi-obvious. However, there is a way to document your function. The way to do it is called docstrings. These are the strings which are added after the function definition, and they are denoted with the triple quotation marks. So typically here you can say calculate hypotenuse from the Pythagorean theorem. Okay, Pythagorean theorem. Okay. So nothing is going to change if you just run the code. However, now if you want to get the help on this function, you can do help on hypotenuse, right? And it prints us, well, the syntax of this function and also this docstring which you have here at the top. So sometimes it's actually convenient to provide more information than just, what the function does. You might want to say that you have parameter a side, and then you have parameter b another side. And then you have the return or the output of this function, parameter c, which is hypotenuse. Well, obviously, I'm exaggerating it for this specific example. Nobody really needs to do it for such a simple function, but when you write in a bigger code with bigger functions, you may want to document it a little bit more thoroughly. Hypotenuse. Okay, so now the help will be printing this syntax of using this function. So there is another way actually to deal with, to simplify use of the functions and to deal with the variables you fit into it, the input and the output parameters. You can actually use the keyword arguments. So one way to call this function would be hypotenuse 3, 4, right? This is what we did. Alternatively, you can say hypotenuse a equals 3 or b equals 4. So if you run it, you'll get the same result. What's important here is when you use this syntax, the keyword arguments, doesn't matter in which order you put them. So if you do b equals 4, a equals 3, nothing is going to change. Well, that's not that important here because both variables, well, it's symmetric with regard to these variables. But I'll show you an example in a few minutes where it might be important. Okay, so another thing which is quite convenient when we deal with functions is the use of the default arguments. So you often want to call a function which use different number of input variables depending on the case. So let me comment this out. I don't need it for now. And let me introduce the next function, well, the next level after my hypotenuse, right? So I'll call it the cosine rule. This is a function which calculates a third side of a triangle given two sides and an angle, right? Oops. So I'll skip the docstring here, but I can input the similar way and document it here. So what I want to do, I want to say, well, if the angle is 90 degrees, it's a simpler formula. It's just the hypotenuse, right? So if angle equals 90, right? And it would be nice, for example, if you're adding the docstring, it would be nice to say that you're expecting your input to be in degrees, not in radians. So you can say, oh, C equals hypotenuse of A and B, right? We already defined the function which calculates it using the Pythagorean theorem. Else, we need to use the cosine rule. So then C equals A squared plus B squared minus 2 times A times B times cosine. Well, I would need to use the math module here, math cosine of the angle. And then all that should be power 1/2. Then I do return C, right? Oops. Need to make the right indentation here. And well, obviously here it's complaining about the what is it complaining about? Anyway, I think the main thing is, oh, okay, it's complaining about this one 0.5, but what it should be complaining, yes, it should be complaining now about math, because I need to import math here. And in fact, if I run this function right now, it's not going to do what I wanted it to do, because this cosine function takes an angle in radians. So I need to add one more thing. I need to do math radians of an angle. So we're converting the angle given in degrees to radians before calculating the cosine. Okay, so I can do print cosine rule. Let's say AB, an angle, and let me choose the sides as, I don't know, 3, an angle of 60 degrees, right? So let's see what it's going to give me. Well, it's giving me the third side, which is pretty much 3, right? With so it works. Well, if I do it with 90 degrees angle, well, obviously the side would be different because it will be the right triangle with the 45 degrees angles. So here, well, if I want to treat this case separately, I can say, listen, I want, if my triangle is the right triangle, I don't want to say explicitly that it's a 90-degree angle. So I can say angle equals 90, and this is the default value for the variable. So if now, instead of this call, I will do print cosine rule and just simply remove this angle. The function will be working, and I will get the same value as above, because, well, if I don't give the value of the third variable, well, it assumes the default value for it. So another thing, and this is actually, well, this example is a nice example where you probably want to use the keyword arguments because your variables a, b, and angle are of different nature, right? So these are in centimeters or meters or whatever, and angle is in degrees. So probably you want to call your function, not to make a mistake. What is what, right? You can say print cosine rule a equals 3, b equals 3, and what I was using angle equals 60. So these, if you call in your code, if you call the function that way, it's much more transparent what each of the variables actually mean. And also, well, it should work and give me the same result as here. And also, you can actually do permutation of this this variable. So if you use the keyword variables, it doesn't matter in what order you're giving it to your function.